Hello, and welcome to Answer Everywhere, the premier show on YouTube about reading code, I guess. So today we're going to look at Tekton, which describes itself as a cloud-native CI/CD thingamajig. We've looked so far this week at two other cloud-native and really Kubernetes-native CI/CD projects. The first was Argo CD and Argo Workflows. You can go check that video out. And then yesterday we looked at Flux. And today we're looking at Tekton. I'm not sure how Tekton fits in with the other projects, Argo and Flux. I'm not even positive that it's Kubernetes native, but it's one of the things I'm considering using for my needs, which right now are mainly CI, although in the future we'll include something like CD. So let's go ahead and jump in. I did take a look before the show just to see, get a very general lay of the land. And then one thing I noticed is that like Argo and like Flux, Tekton is divided into a ton of different like micro Git repositories. So this seems to be the common architectural pattern. I'm not a huge fan, but we'll see what we see. Since we have so many repos, I think I'm going to start on GitHub this time. I'm using Go Please, which is the Go LSP server on Emacs, and the past few days it's been really slow. So I'll start by getting a feel for like maybe what the right repositories are, and then if I need to dig deeper, I'll move on to onto Emacs. So maybe I should start with the operator. The operator should presumably be the thing that is doing the control loop stuff maybe in Kubernetes. I'm assuming this is Kubernetes. Is that right? Let's verify that. Hello, Harry Hopkins, and welcome. All right, so this is Kubernetes stuff. That's good. Well, good for me. Maybe it's good for you. Dashboard should just be a UI. Chains, I think, should be, we're going to chain together different pipeline-y things. These should be, maybe these are like the Lego building blocks of Tekton. And then we have triggers. And triggers should be the things that you use to decide what should trigger a build, for example. And what else do we need? Results might be interesting. Community we will ignore. I don't know what Tekton Hub is. I think Tekton Hub might be like a place you upload your Tekton thingamajigs, and a pipeline should probably be pretty fundamental. And is that it? Did we open chains? We did not open chains. Catalog, a catalog of shared tasks and pipelines. Let's look at catalog, I guess. And maybe that'll give us a sense of what Tekton is supposed to be up to. So let's start with catalog. And if you want V1 alpha sources, you need to go to the V1 alpha branch. The main branch is synced with V1 beta. Fair enough. So each resource has the following structure. We've got some task, which is a kind of resource. Argo CD, the definition file must be the same name, must have the same name. I don't know what that means. I guess this is like an Argo, maybe like a Tekton build that's kicked off by Argo CD. And who, I don't know. I don't know what that's trying to tell me, but let's look in task. And as example tasks, they have things like Ansible Builder. So I guess you're going to build stuff with Ansible using Tekton. AWS. Bentami, I'm not, BentoML, I guess. Originally, I read that as Bitnami, but I don't know what that is. I don't know what BentoML is, or Black, or I guess blue-green deploy is going to be some attempt to build blue-green deploy things. Is there anything super fascinating for me to look into here? I'm not sure. Let's look at Pylint. Let's look at Pylint just for fun. So we have 0.3, and we get a YAML configuration file. I'm not sure if this is Kubernetes, but it looks very Kubernetes-ish. We start off with API version. The kind of thing it is task. I don't know if task is a thing that's built into Kubernetes. Tasks. Yeah, I don't think this is I think maybe Tekton defines the task object. I guess that's what this means. It's like a thing in this like API CRD space or whatever it's called. All right, and at any rate, how do we configure the task? We have a thing like a name, some annotations. I guess this will tell us its code quality, what versions we have. These are like tags, the display name, I guess, for the UI, and workspaces. And the workspaces are source, which has custom pip settings and whatever pip conf is, I guess, to configure pip. And then some parameters, including presumably some sort of disk image. So like, so this is some container image. It's gonna have this pylint container. And then we have the path to the module, which would be analyzed. This looks nice. This looks like the sort of thing that I would be into. Let's see if we can figure out Argo CD example workflow configure for pylint. Let's see if we can see something similar for Argo CD. I'll try just asking the AI. So generate an Argo workflow config for running pylint on a code base. Hey, Cynthia, thank you. No problem. They say, thanks for doing this. So here's what ChatGPT thinks is a workflow for pylint. It's got, or for Argo CD, just to make that clear. So this is a workflow kind in the Argo Proj API version thing. It's using the pylint workflow dash thing to, I guess, generate name. Maybe this is like the prefix that's used to generate names. The entry point is pylint, and we've got some container, and we run this arg. So that's reasonable. That's pretty close to how you would do it if you were just to create like a Kubernetes job and run it with kubectl. I feel like so far, kind of like the Tekton way, but we'll see. We'll keep digging. All right, so that's Tekton catalog. That's enough for me to see there. Operator, I'm not sure how important operator is. We've looked at a couple of operators, and we're definitely not going to like dig into the all of the details of everything it's doing, but maybe we can at least find where their main operator code is, perhaps in command, because everything was in command for Flux. We have main.go, and this is just doing command line-y stuff, I guess. So it's going to get a new platform config and set the Kubernetes platform based on the config. It's going to call start main with selected controllers. Okay, so that's kind of just setting things up. Vendor, I'm going to guess, is vendored resources tests or tests. How about Tekton? Tekton looks promising. We've got a customization and a bunch of YAML, and then not much else. The Tekton operator repo CI/CD. Okay, so that's not what I want. Chart is probably not what I want. Hack is probably not what I want. Maybe package. And we get APIs, client. How about reconciler? Okay, common Kubernetes. So we want the Kubernetes reconciler. Let's look at Tekton chain and controller. And just want to get just a quick look. So this is 86 lines. So it's not huge. New controller initializes the controller and is called by the generated code. Registers event it registers event handlers to enqueue events. So we just call new controller. We give it a context and a config map watcher. And it's going to return a controller implementation just by calling new extended controller with no extension. And then here's the general new extended controller that might have an extension. And we set up a logger. We do whatever this is. I guess set up the controller object which just has a logger and a config map. And then we, I guess, call init controller with some payload options. I don't know what those do. And then et cetera, et cetera. This is all set up. And then where do we actually control? Maybe the controller is in common. But let's also look at Tekton chain just to make sure there's nothing fundamental that we're missing. This is much longer. And we have symbols. Chains config, reconciler. Let's look at reconciler. Implements the controller.reconciler for Tekton chain resources. So what do we expect this to do? I'm not sure. I have no idea how Tekton works. I'm guessing Tekton has some sort of backend service that's going to keep track of the whatever chains are, their various states, and like monitoring them and making sure they're making progress. And so the reconciler's job should be to look at maybe like the progress that's actually being made by chains or whatever, and comparing that with the desired progress and taking some sort of steps to intervene. I don't know what those steps to intervene are, but maybe we will see what they are. Or maybe it'll be a little bit opaque. Okay, so we have some manifest. The manifest has the source manifest of Tekton triggers for a particular version. Okay. So we're selecting stuff with selectors, getting configs and secrets and whatever ls is. Labels, I guess. We can reconcile kind. It compares the actual state with the desired and attempts to converge the two. Okay, this seems like the money function. So we give it a context and a Tekton chain. And it's going to return a reconciler event. Okay. So we initialized and some stuff, logging and whatnot. We're going to call this chain resource name function with whatever this is. Let's see if I can zoom out so I can get the full text width. Okay, so this is some error looking stuff. Okay, so I guess this is just checking that the resource name is appropriate. Then we're going to find a valid Tekton pipeline installation. So we're going to check if pipeline is ready. And so I'll just assume that our pipeline is ready. We're going to set defaults. We will mark the Tekton chain instance as not ready if an upgrade is needed. Okay, so we check if an upgrade is needed, in which case we return an error. Or rather, yeah. And whatever pre-reconcile is doing, I guess it's like a hook that you can add pre-reconcile stuff to, and then we'll mark pre-reconcile complete. And then we'll do this stuff, which gets a long comment. Fetching and deleting the chains Tekton installer set to delete chains config map to handle the scenario when user upgrades, i.e. in previous version, chains config map installer set was not there. With the latest version, we create separate installer set for chains config map. I have no idea what that's trying to say. I suspect that maybe the author of this may not, English may not be their first language. So I don't think that I can quite read this literally, but I think what it's trying to say is, for some reason they're fetching to delete chains config map to handle the scenario. So there's some scenario we need to handle. What is it? It's when the user upgrades. Whoa, now. In the previous chain config map, installer set was not there. In the latest version, we create separate installer set for chains config. There's something about the config map maybe didn't have some config, maybe the chains config, whatever that is. The installer set. And maybe we push a new config map with that. maybe it's doing that sort of thing. There is some ugliness in Kubernetes, I think, with config maps where if you change a config, that new config won't necessarily be updated until you restart the pod. They might have fixed that. I'm not sure if this is working around that sort of thing for some reason, but at any rate, it's just checking some label selector and returning an error. Actually, this whole thing seems to be governed by the comment. So we're getting the current installer set. And if an error, we return just the error. And then we check if we have an existing installer set and whether it's essentially non-empty. If it exists, then fetch the Tekton chain installer set. And we're going to fetch it, I guess, from where? Maybe from essentially etcd or from the Kubernetes cluster. And if the installer set release version is not the operator version, then we're going to delete the existing chain installer set. Okay, so I feel like this is kind of a workaround. This is just setting up installer sets. Who knows what installer sets are? I assume that they're pretty fundamental. But this, based on the comment, it sounds like this is kind of like working around an issue that they hadn't considered before when they originally wrote this, whatever their first version of the function was. All right, so if it exists, we're going to fetch the installer set. All right, and then we're down here. Now we get a long comment about checking if the target namespace of the existing Tekton chain config installer set is the same. Okay, so more installer set stuff. Is it all installer sets all the way down? Check if installer set already exists. Do more installer set stuff. I would maybe factor out the installer set unless it's all about installer sets. And this whole function is maybe a little bit, for example, I'm zoomed in a lot because I'm showing this on the screen, but we get if conditions that are like almost the full height of my browser window. And we get like a few of them. And we've got like the kind of recipe style where like, there's a comment and then we're going to do a bunch of stuff. And then there's another comment and we're going to do a bunch of stuff. I'm wondering if maybe this could be restructured a little bit to kind of hide the implementation details of maybe some of this stuff and make the logic a little bit more transparent. I'm not sure. Okay, so if at some point we get down here, if target namespace and version are not changed, then check if chain spec is changed by checking hash stored as an annotation. Okay, so this is interesting. So you can change the target namespace and version. And somehow it sounds like Tekton's going to try to handle that. And in theory, namespaces should be independent, but I guess this is like Tekton is maybe like cutting across namespaces in some way. And then we check if a chain secret installer set exists and do some stuff. And then what? I don't know. Maybe this is where the stuff. So if the installer set is available, okay. So if we're down here, then the installer set seems to be available, and we're going to mark it as available. Okay. And then we're going to get its condition, I guess, and make sure it's not an error. And then we're going to mark the installer set ready. And then we're going to call post reconcile and mark post reconcile. So it really does seem to be all about installer sets. So whatever an installer set is, that seems to be maybe at the heart of things. And then we have finalize kind, which is going to remove all resources after deletion of a Tekton chain. So is this like the garbage collection thing? And if so, do we care? Like as a chain, I think cleaning up a chain, whatever a chain is, that might be different from like deleting cloud like resources like namespaces or pods or whatever. Delete CRDs before deleting the rest of the resource so that any instance of CRDs which has finalizer set will be deleted before we remove the controller's deployment to it. Yeah, so I'm not sure. But let's look up what an installer set is. And I'm gonna try to just look it up in the documentation. How about here? Can I search the docs? Okay. I think I'm going to jump to Emacs unless this GitHub's going to let me like click on an identifier, which it might. So we import this thing, reconciler / Kubernetes / Tekton installer set. Is that where we are? Operator. How about operator package, reconciler, Kubernetes? Okay, let's look at installer set. Do we get a README? No. But we do get Tekton installer set.go. So Centil has a suggestion. Should we look at the documentation and find entry points for the commands and start following the code class after class from there? We can do that. Let me do a little bit more of this first. I mean that's kind of that's a lot like tracing from like tracing the execution of a thing, which is really really useful when you're debugging, and it is really useful I think for some types of repos, and this might be one. So we'll try it. But I find that it works less well I think than you would think before you try other things. But let me take a look at this installer set thing a little bit to see if I can figure out what it's really about. Okay, so we've got reconcile kind. I don't know. Handle error, reconcile kind. Installer set. So what is an installer set? Like we have a reconciler, which is a struct. We've got a finalize kind and get reference. I'm not sure. I feel like I'm looking for a struct. Let's look at install. Installer is a struct that has a manifest and a client, a logger, some CRDs, cluster scoped and namespace scoped. These are maybe CRDs that are scoped in that way, and then we have deployments. And so I guess what an installer is going to do is install things, I guess, based on CRDs. Is cluster scoped. So here's some things that are cluster scoped, for example. Component status, namespace, node, persistent volume, yeah, mesh policy, token review, okay. And all right. So let's look up installer here. Maybe installer set is not the right, what's the word? Right, granularity. Can I get like a Tekton concepts? Maybe there is a concepts and I just ignored it. Let's try this. Let's try this on their terms. Concepts. All right. Overview. Let's see. What is Tekton? I don't care about that. I want to know about the implement. I want to know about the architectural design. Concept model, maybe? Okay, so a step is an operation in CI/CD workflow, such as running some of the unit tests for a Python web app. A task is a collection of steps in order. So we saw a task, and I guess so we saw the steps. So we saw the pilot task, and I guess each of those little, not like stanzas, but like each maybe sub stanzas in pilot, I guess is probably a step. And then a pipeline is a collection of tasks in order that maybe form a DAG. What's an installer? I don't know, but here's a pipeline. Step 1, step 2, step 2. This is task A, B, C, and they have some graph relation that's a directed acyclic graph. Task runs and pipeline runs. A pipeline run, as its name implies, is a specific execution of a pipeline. Okay, so this should be the sort of thing where you like open up a web UI and you're like, oh, the pilot pipeline is failing now, but it was not failing 2 days ago. So a pipeline run should be the thing that tells you like, this particular run of the pipeline is doing this, I assume. For example, you may ask Tekton to run your CI/CD workflow twice a day. Yeah. A task run is a specific execution of a task. Okay, so then I guess pipeline runs probably have like references to task runs. How Tekton works, loosely speaking, at its core, Tekton pipelines function by wrapping each of your steps. More specifically, Tekton pipelines injects an entry point binary in step containers, which executes the commands you specify when the system is ready. So we saw in the Argo CD thing that you just give it like a container and an entry point. And what Tekton is telling us is that it works by like each step. It just essentially creates the same thing. It creates a config for the container and the entry point. It's just like adding the keyword entry point to your config. But I guess the idea is that you can look at this pipeline and see all of the steps without the clutter of thinking about the implementation details of like, is the entry point start pilot.sh, or is it the pilot binary itself, or is it setup pilot, that sort of stuff, I guess. So Tekton Pipeline tracks the state of your pipeline using Kubernetes annotations. Okay, so whoa now. So I guess that what that means is that the things that you annotate are like the YAML files, right? So I guess that you have some like Kubernetes resource that corresponds to the pipeline, and they're going to update the resource maybe with annotations. These annotations are projected inside each step container in the form of files with the Kubernetes downward API, which I completely forgot what that is. The entry point binary watches the projected files closely and will only start the provided task if a specified annotation appears as files. Watches them closely. I feel like if you're going to watch a file and you're on a computer, there's only so much closeness. You either are watching it or you're not, right? For example, when you ask Tekton to run 2 steps consecutively in a task, the entry point binary injected into the second step container will wait idly until the annotations report that the first step container has successfully repeated. That's actually kind of interesting. In addition, Tekton Pipeline schedules some containers that run automatically before and after your step containers. Okay, I still don't know what an installer is, but that's fine. This was all pretty interesting. And let's real quick see if we can find out what the downward API is. In Kubernetes, there are 2 ways to expose pod and container fields to a running container: environment variables and volume files. Okay, so it's a way to expose, I guess, like pod stuff to the containers, which are like the implementation details. Okay, so let's go back to Sentil's recommendation to look at the documentation and find entry points for each of the commands. So Sentil, if you're still here, what do you mean by a command? Do you mean like the command line commands? Let's see if I can find Tekton command. So here's the CLI. Clone a Git repository, build and push an image. Let's look at build and push an image with Tekton. Okay, install Tekton pipelines, etc. Clone the repository. Yeah. So this is some configuration. It's going to tell us to do what? Some pipeline that's clone, build, push, and it's going to do some stuff. What's it going to do? Fetch source with, I guess, git clone, task ref. I think I'm missing I believe that Tekton is supposed to be composed of like, I guess, composable, reusable parts, and maybe git clone is one of them. And I think maybe Tekton Hub is a place for you to like browse reusable workflowy things. And so maybe let's take a quick look at Tekton Hub just to see what things look like. And then so we're going to create this pipeline file that's going to do the stuff I just mentioned. And then we will create, I guess, manually the pipeline run YAML that has this generate name thing, clone, build, push, run, a security context, whatever the FS group is, 65532. Okay. And we're going to use the shared data workspace with whatever some volume claim on it. And the parameters are the repo URL. And it's going to tell us to build and run, in particular, this thing. But it doesn't know what to run. It's going to fetch stuff. It's going to clone it. And then, oh, so this is just cloning, right? Okay, so we're going to build a container with Canico. To build the image, use the Canico task. Why Canico? Build and upload container image using Canico. What is, I don't know what Canico is. Oh, it's a Google tool. Build images in Kubernetes. Canico is not officially supported. Okay, so this is some thing that doesn't depend on Docker and builds images in a Docker file inside a container or Kubernetes cluster. This looks super useful to me because I'm tired of running a Docker build server. Okay, that's actually pretty cool. Thank you, Tekton, for telling me about it. All right, and then we're going to create a build push thing, and it's going to build and push some stuff. The new task refers to Canico, which is going to be installed from the community hub. This should be the Tekton hub, which we will look at. And then we instantiate the task by adding it to the pipeline run YAML. And then we might need might need to authenticate to the container registry. Okay. And then we're going to run the pipeline by calling Tekton hub install task git clone, Tekton hub install task Canico. Okay. So, oh, hello, Grang. So Sentinel, so I'll tell you what I see, and like you can give me feedback about what in particular you want to see. So the command line, I'm going to wager 5 imaginary internet points that the command line is not interesting, because what it's going to do is it's going to call kubectl essentially. So this is installing the tasks. And the way that you what are these task things? They're the YAML files we just generated, right? So the interesting bits, I think, are not so much in the command line, which should essentially be a fancy wrapper around kube control. The interesting bits are like what happens once the YAML is in the cluster, and that's going to be stuff like the controller, like I was looking at. So okay. So, and then you're saying, so we can start by finding out which class is the entry point when we create and run a task in Tekton, and follow from there. When we create and run it, which class is the entry point? When we create and run, so, okay, so a task or a pipeline. So let me look in tasks. Do we have the tasks? Is there like a task? So we have chains, which are supply chains. We have hubs and pipelines. Let's look in pipelines. So the way that it should work, if I'm understanding correctly, is that the entry point is, assuming all of the apparatus of Kubernetes is already functional and whatnot. The entry point is that once a task exists in the Kubernetes cluster, essentially in the etcd database, then the entry point from a certain point of view is really the controller. And so it's the controller that's going to be watching for changes, noticing that you've uploaded a task or a pipeline, and then orchestrating the building of stuff. And so that's why when I was looking at whatever that thing I was just looking at, I don't remember which repo that was, but I went directly for the controller, because from my perspective, that's really the entry point. Now, obviously there's some main function that might set stuff up and gets the controller running, but that in a sense is not really I don't think that's the logical entry point, I guess, is what I'm trying to say, to the pipeline infrastructure. So let's try taking a look at the pipeline thingamajig, pipeline controller, and see if we see anything there. So I was looking at operator. So operator should be what? Is this the thing that makes sure that like Tekton stays installed and whatnot? The Tekton operator, this is the thing I was looking at before, right? So Tekton operator is a Kubernetes extension that is to install, upgrade, and manage Tekton CD pipeline. Sorry, to install, upgrade, and manage Tekton CD pipelines, dashboards, and triggers. And what's it do? So each Tekton component has a custom resource, which installs the component and manages it. Tekton config is a top-level custom resource which creates other components. So the user just needs to create Tekton config with the required configurations. Okay. So the operator, I'm not sure exactly what I think that the implementation details that we seek are going to be in pipeline. I'm not sure, but let's take a look. I think the meat was in package. And then here we have controller, credentials, container, and a bunch of other stuff. Reconciler, results, Spire. Spire might be the security stuff. Substitution, task, run metrics, termination, trusted resource, and workspace. So let's take a quick look at controller. We just have filter.go. That can't be so interesting. Returns and filter that can be passed to a custom run, etc. Okay, we'll ignore that. How about APIs? This might be closer to what you're thinking of as an entry point. Let's look at pipeline. We have things like images, register. How about V1? Container types, param types, pipeline defaults, pipeline types. Is there just the pipelines? We also have provenance, which I think is pretty interesting. That should keep track of things like guarantees that your container was built like from a Tekton pipeline as opposed to just being built on some developer's machines. Let's look at pipeline defaults. This is like setting in default. That's not so interesting. Maybe pipeline's not the place to go. Let's look at reconciler. Okay, so how about a task run? And again, we get controller and task run. Let's look at taskrun.go. And Sentil, if you're still here, let me know if taskrun.go is the sort of thing that you had in mind. Although we may not have found it by the method you were suggesting. Okay, so Chang, I'll read this in just about 1 minute. Okay, so the reconciler implements controller.reconciler for configuration resources. Okay, and the reconciler is a struct that has a kube client, like kubectl, a pipeline client, some images. I don't know if those are container images. We've got a clock, and listers, index properties about resources. So things like lister. I don't know what listers are. I guess it'll list things like list pods, list metrics. Okay, that sounds good. And here's just like some setting up stuff. So reconcile kind, I think it's going to do it's going to be the framework for doing the actual work. The implementation might be, it might be calling interfaces, and the implementation of the interfaces might be in other files, but I think that this is a useful entry point. Okay, so whatever a span is, defer span end. Okay. So we check if the thing has started. If the task run is just starting, this will also set the start time, from which the timeout will immediately begin counting down. Okay, so we'll have a timeout for our tasks for each task. Each task is composed of several steps, but there's a timer for the whole task. There might be step-specific timers. I don't know. We'll check if the task is done, in which case we'll run some post fixtures when applicable. And for example, still stop the sidecars, I guess, potentially. And we'll call finish reconcile update emit events. We'll check if it's canceled. We'll check if it's timed out. We'll check if there's some sort of pod failure. And then for down here, it says prepare fetches all required resources, validates them together with the task run, runs API conversions. I'm not sure what API conversions are, but maybe like legacy API support. In case of an error, we update, emit events, and return. So prepare is going to do all that. There's probably a lot of meat in the prepare function. Can I go here? No, I can't go here. That's okay. Maybe I'll open this in Emacs in a minute. We'll store the condition before reconcile. So we'll just store where we are before we start the reconciliation process. We're going to reconcile this copy of the task run and then write back any status updates. And we're just calling c.reconcile. So what is c? I'm not sure. We must have pulled it from somewhere. Let's check this in Emacs in just a minute. And then essentially we're delegating to whatever c.reconcile is, and then we're finishing reconciliation. So let's look at c.reconcile. That should be closer to the implementation. Then Chang is saying, do/why you think read the code is an important skill for a developer. Can you suggest some stuff for that the junior developer can read? That's a good question. Yeah, I do think. Yeah, so if you're a developer, you're going to be spending more of your time reading code than writing code. That is maybe less true of junior developers, but eventually it's going to be true at some point. And then at some other point, you're going to be spending most of your time in meetings rather than doing anything with code. So in that sense, it is important, and I think it does expand your sense of how other people who have more experience with you than you write code, and more experience than you, I think, can be interpreted like really broadly. Like you may be a really outstanding, let's say, Go developer, but it might be useful to read like stuff that really strong developers have written in other languages, just to expand your horizons. And then as far as like stuff that the junior developer can read, I feel like that's a really good question. It might depend on the language. What I hear from Go people is that everyone should read the Go like standard library, which I haven't done. And I think if you're junior, the way skills work in general is like when you start, you don't know what you don't know. You don't really know what the gaps in your knowledge are. And so sometimes this is called, what is it, unconscious incompetence. And then you progress to conscious incompetence where you're like aware of what the gaps are, etc. So when you're not so sure what the gaps are, I think it's probably important to not read terrible code, like buggy code, because you haven't developed like a sense of taste yet. And so I guess you should probably read like established projects that are well regarded. It might be a little bit boring, but are well regarded in whatever programming language you want to use. And other than that, try to read things that have an interesting topic to you, I guess. So if you like games, read some games, but try to find like good, well done games, because GitHub is full of people who are learning as they're doing projects. And so so when you're learning as you're doing a project, that's kind of like at the edge of your competence. So another way to say that is GitHub is full of people writing code that they're that's expanding their brain, and so isn't their best work. They will look back on it a few years from now and realize that they were still learning, but probably realize that the code was terrible. That's a common occurrence. Okay, so let's go to where I was in Emacs. So package, reconciler, task run. Where am I? Pipeline. Oh, package. Okay, reconciler. Okay, so all of the reconcilers seem to be in the same place. what we call like c.reconcile. So where is c defined? Okay, so we're just on, so c is just the reconciler. So here's the reconciler struct. And so we were looking at reconcile kind. And so the thing the thing that we are ultimately calling is c.reconcile with a lowercase r, which I guess is like an internal function. Reconcile creates the pod associated to the task run and pulls back status updates from the pod to the task run. It updates errors back to reconcile. It updates the task run status in case of error, but it does not sync updates, etc. Oh, it does not sync updates back to etcd. It does not emit events. Reconcile consumes spec and resources returned by prepare. Okay, so it reports errors back to capital R reconcile. It updates the task run status in case of error, but the errors don't make it to the database, to the etcd, to the Kubernetes cluster database. I don't know what the design reasons for that decision are, but you're welcome. But that's how things are. Okay, so this should be close, or much closer, I guess, to what Centil was asking for. So now we're scheduling pods, right? And so how are we going to schedule pods? It's Kubernetes, so we're going to create YAML and send it to the etcd server. And so what YAML are we going to create? We're going to create the YAML that's described in the YAML that you use to define your task. And we're going to like slap a entry point on it, and otherwise just raid the, we're going to raid the task YAML definition thing for all of the information that we're going to use to create maybe either a deployment or a pod or a job, some Kubernetes native object that's going to actually run a container and do the containery stuff. And so let's see if that theory is true. So what is TR? So okay, TR is task run. So we're going to check that the task run name is not non-empty. Whoops, I'm not in God mode, so I can't do that. Do some error checking. We're going to list pods that have label with this task run name. Okay, so we'll see if there are other pods running for the same task run name. This does not include other labels from task run in the selector. The user could change them during the lifetime of the task run, so the current labels may not be set on a previously created pod. Okay, so the absence of labels, I guess, doesn't mean that there's no corresponding pod. And this is just going to list stuff, right? Please note that this block is required to run before apply params constant context results and workspace is called. Okay, so we're going to check if the pod is nil and has a volume claim template. I don't know why a nil pod would have a volume claim template, but I guess that's possible. We're going to get the randomized volume names assigned to workspace bindings. So we're going to get some workspace volumes. I'm not sure what's up with the workspace. I think that maybe part of the thing with workspace is like you may not want your like CI containers to be completely disposable. One example is something like maybe like Bazel, where you might have cache or a gigantic Git repository. You may want to start with a checked out Git repository in your thing that you're going to build in your workload container, and then just synchronize with the changes that have elapsed since that container was created or whatever. So that will prevent you from doing a full sync every time or what have you. So I think that maybe that's what that workspaces are about, having this sort of like long-lived state that persists between runs, but I'm not positive. We're going to apply params, context results, and workspaces to the task run. So I guess this is modifying the task run YAML stuff, which I'm calling YAML, but really this is all in memory. This is like Go structs. So we're going to, I guess, I'm gonna still call it YAML. We're going to modify that YAML file essentially, adding things like context and workspaces that might be, I guess, at the pipeline level or at some level above tasks. And so it doesn't need to be explicitly included in tasks. We're going to, whatever this is, set the task spec to TS and do what? If the pod is nil, then we're going to create it. And this is the thing that's going to create, this is going to kick off the chain of the chain of events that's going to run the build, right? So when we call create pod, I believe, are telling Kubernetes to create the pod, like kubectl create pod, whatever I think is the command. And this should essentially start running stuff because we get a pod back, which should be a reference to the like thing that Kubernetes returns once a pod is created. But let's double check this. Are we in Kubernetes or we're in pipeline? So create pod creates a pod based on the task's configuration. So let's look at this then. So create pod is going to take a task spec and a task run. So TS is the spec, TR is the run. Whatever a resolved task is, and a workspace volumes map. And so this should be the thing that assembles YAML. I can feel it. I'm not positive. All right. So, all right, we got logger. We're going to do a deep copy. We don't want to mutate it inside the create pod function. It's possible that pod will be killed before running, and when rescheduling it will cause bugs. As this function could be called multiple times, we copy the task spec to help in scheduling pod. Okay, so we do a deep copy to avoid like badness. We validate stuff. We apply something we call workspace apply with the task spec and the workspaces and the workspace volumes, and we get back another task spec. Check for errors. We apply the credentials path. Apply path substitutions for the legacy credentials helper. I guess that's legacy stuff. And then we have a pod builder. And the images are going to be the images that were passed in with, I guess, the images that the reconciler knows about. I think we're still in reconciler, right? So I think C is still the reconciler. Let's see if we can scroll up and verify that. Yeah, C is the reconciler. Okay, so these images, what happened to my images? Yeah, so the images are the images that the reconciler knows about. The client set is the stuff. This is all just coming from the reconciler. And then we're calling pod builder.build. And is this calling the Kubernetes API yet? No. Build creates a pod using the configuration options set on B and the task run. So again, we're getting a thing that takes a task run and a task spec. So maybe I was wrong. Maybe this is where stuff is assembled. And here we're getting volume mounts. Whatever bin RO mount is from. We have some transformers. So there might be more than meets the eye. Okay, so we're appending volumes. I don't know where bin RO mount, but I guess that's read-only mount. Binary read-only mount, some source of binaries. I guess binary storage, I don't know. Then we're going to create volumes and volume mounts for any credentials, etc. Merge steps with step template. This looks promising. So we've got some step template ready to come from the task spec that we passed in. And we're going to take the task specs step template and merge it with the task specs steps to get the steps. And then we're going to merge it with the task run step specs. And then we are going to apply task level compute resources. And I don't know what they are, but maybe things like whether you need a GPU or whether you need certain CPUs or some amount of memory. We might use Windows, in which case we need to record that. We might have sidecar loggers. Sidecar logs results enabled. I guess there's like a results sidecar that's going to run alongside the task run and report results. And if so, we are going to merge the specs. And then we're going to call entry point init container with the image's entry point image, the security context, the steps, and whether we're running Windows. And this is looking probably like a Kubernetes thing. Whoops. Where did my explaining window go? Do I not get to examine it? Okay, whatever. All right. And then we're going to convert any steps with script to command plus args. So I guess the script has a capital S. So I'm guessing in the Tekton YAML stuff, there's something that's called script. And that's like a convenience. That's like syntactical sugar, I guess, for it's going to be converted into the more Argo CD style, at least as created by ChatGPT. I don't know if that's the real Argo CD format, but it's going to say like this, here's the container, here are the commands to run, as opposed to being like a separate scripts thingamajig. And then we're going to initialize any working directories with whatever working directory init is. By default, use an empty pod template and take the one defined in the task run spec, if any. So we're going to get an empty pod template, possibly use the one from the task run spec. Resolve the entry points for any steps that didn't specify a command. I don't know how they're doing that, but they're going to try to figure out the entry points. And then we'll call is ready immediately, which depends on the feature flags and the sidecars. We'll check if the alpha API is enabled. Appends volumes. If we're not ready immediately, we'll append more volumes, including the downward volume. And whatever, some environmental variable stuff that might be filtered. I'm not sure what slices is, but some filtering stuff. And then this looks like sanity checking about the length of the template. Here's some annotation stuff. Add env var if hermetic execution was requested. So we might set annotations saying that, like hermetic execution was requested. And then we're going to iterate over step containers. So we have a bunch of containers, I guess one for each step. And we're going to do some stuff. We're going to mount the Tekton creds with a fresh volume for each step. It needs to be world writable and empty. So creds can be initialized in there. Okay, so we're going to add credentials to each of the volumes. We're going to add Tekton run state volumes. So we have state. And we've got some amount of requested volume mounts that maybe these two things seem like Tekton is mounting stuff on your behalf. Maybe requested volume mounts is things that you've requested to be mounted. And we're going to set the volume mounts appropriately. We might do some stuff for sidecars. And then we're going to iterate over the step containers again and set their names using the simple name generator with the step name. So the simple name generator has like a prefix. The step name is the suffix, and we're going to restrict length, I guess, so we don't go too crazy on length. And then we're going to add pod template volumes to the explicitly declared use volumes. So we're doing more volume manipulation. We're going to validate the volumes. Check if Spire is enabled. So let's look up Spire real quick. Maybe Spire Kubernetes. I think Spire is spiffy. Okay. So it's something to do with certs and maybe client certs. Let's look about Spire. A production-ready implementation of the spiffy APIs. And spiffy is the secure production-ready identity framework for everyone. A standard for defining how devices identify themselves to each other called spiffy IDs. Yeah, okay, something to do with identity management for like machines as opposed to humans. Okay, so we might have some machine identity stuff enabled, which is cool. I think it's cool. I hope you think it's cool too. And then we've going to define merged pod containers to be the step containers. And then we're going to merge the sidecars. Maybe have some stuff with DNS policy. This is looking really advanced. Then we have pod annotations. We're going to copy the task run annotations to something or other. At least we're going to, I don't know what we're doing with it, but we've defined this variable. If ready immediately. Okay, so if it's ready immediately, then we're going to set the pod annotations to the ready annotation value. And what else are we going to do? Or rather, we're going to set that ready annotation. We'll set the pod name suffix to pod. Do something with task num retries by, so the retries are going to be, I guess, manifested or made visible in the pod name suffix. So I guess when you do like maybe kubectl list pods in the namespace that has all the Tekton stuff, I guess maybe the pod name will tell you which retry of this, what are we, events pipeline? I think we're in tasks. This thing is running. And then we're going to, and finally, we're going to create a new pod. I think this is just creating the pod object and not communicating with Kubernetes. But you can see how we're laying out all this stuff. So we've assembled the stuff. The way that we lay it out should now be really obvious. And so I'm going to mostly skip over it. And then we're going to iterate over the transformers. And they're going to transform the pods. Okay, that's kind of cool. And then we're going to return the new pod. Okay, so this function is like this is like 3 iterations deep from where I started. I'm going to go 4 iterations deep because I want to see one of these merge functions. How about merge steps with step template? Merge steps with step template takes a possibly nil container template and a list of steps, merging each of the steps with the container template. So this should just be merging YAML. So we're going to get merge data by converting the template, I guess, to a Kubernetes container and passing in an empty container object with it. And then iterate over the steps. And then we're going to call merge obj with template bytes. And amend conflicting container fields, etc. Okay, just a quick look. Now we're back in task run go. I forget exactly what the name of this function was. This is, fail task run. Create pod is where I want it to be. Okay, so create pod is calling the function I just looked at, right? Pod builder. Okay, so pod builder is that what I just looked at? No? Pod builder.build is what I looked at, right? Yeah. So pod builder.build is doing all the work and returning a pod object, which I think we decided was not yet persisted to Kubernetes. And so Kubernetes is not going to start kicking off work. And so when we're on line 763, we haven't yet started the chain of events to kick off a build. But I think that down here, this must be it, right? So we've got this kube client and some namespace, and we're going to call create on the pod. So on line 774, this is when we start kicking off that chain of events. We're going to essentially persist the pod configuration we just assembled to the Etsy database. Some pod reconciler in Kubernetes is going to see it and start running. It's going to tell the the container runtime to do containery stuff and run your code. And then that pod may have failed, in which case we're going to return some sort of error. I guess if it failed to be created, it sounds like we're not waiting for the pod to run to its entirety. Okay, so that was really informative. What does the controller do? I don't know what the difference between a reconciler and a controller is. The new controller is Nancy, it's a new controller. Let's ask ChatGPT. In the Kubernetes ecosystem, or how about in Kubernetes, what's the difference between a reconciler and a controller? Did I spell this wrong? No. They're often used interchangeably, but they refer to slightly different concepts within the context of managing and maintaining desired state. So a controller, maintaining desired state for a particular resource type, for example, pods, deployments, and services. Controllers continuously monitor the actual state of resources and compare it to the desired state as specified in the resources configuration. If there's a difference between the actual and desired state, the controller takes actions to reconcile the two states. Maybe the reconciler is just the reconciliation logic. A reconciler is a more general concept that encompasses the logic and processes responsible for reconciling the desired state and actual state of resources. A controller is essentially a type of reconciler that specifically manages a particular kind of resource. Reconciliation involves comparing the, Reconcilers typically follow a pattern where they watch for changes in the desired state compared to the actual state and then apply changes if needed. So in summary, a controller is a specific type of reconciler that is responsible for managing a particular type of resource. Okay, and how do these differ from an operator? I think an operator is for like making sure that the Kubernetes stuff is installed, like the CRDs maybe. An operator is an extension of the concepts of controllers and reconcilers in Kubernetes. It is a method for packaging, deploying, and managing a Kubernetes application. Okay, so it's like application management. Typically a complex stateful application using custom resources. Operators are built on top of the Kubernetes API. All right. Well, I'm going to also ask Bard how reconcilers and controllers are different. I'm not saying that ChatGPT is wrong. I'm just not 100% positive that this is the whole story. Wait, do I not get to do a new chat? So Bard tells me in Kubernetes, a reconciler is a function that is responsible for bringing the current state of a Kubernetes object closer to its desired state. A controller is a piece of software that manages one or more reconcilers. Okay, that's more consistent with what we're seeing in Tekton. So the controller is going to manage reconcilers, and the reconciler is really just the thing that's going to run the logic to reconcile stuff. Okay, so now we should be about an hour in, maybe a little bit over. Let's see where we are. An hour 12. I think I'm just about going to stop there. I feel like of all of these, Tekton seems the coolest to me. It seems like they really thought through a lot of things. And there's a complexity to the code base, which isn't always good. But the complexity so far is all things that I feel like I would like machine identities and the way that it uses like the annotations and the downward API. That seems very Kubernetes native to me. Oh yeah, the last thing I wanted to do was check out Tekton Hub to see what the hubbub is about. Okay, so Tekton Hub. So the problem with all of this sort of Tekton Hub sort of stuff is that if Tekton becomes huge, maybe it's huge, I don't know. But if it becomes huge, this thing is it's like an app store. It's going to be littered with like 600 different ways to do the same thing. And they're all going to be like slightly different and like all different, like slightly bad in one way or another. So that's the usual problem that I see with this sort of like plugin, like community plugin approach to stuff. On the other hand, maybe there's enough in here to justify it. And so just for fun, let's see if we can. Oh, there's only two pipelines. We have build packs and build push GKE deploy. Let's look at tasks. And are these sorted by popular? Send to Telegram. Trigger Jenkins build job, rather. Helm upgrade from source. Builda, which is like the Podman builder thing. AWS CLI, Argo CD. Okay. There's some stuff in here. Looks pretty cool. All right, so that's Tekton. And this is concluding our look at all the Kubernetes native CI/CD stuff. I'll be back next week. Not sure with what yet, but I'll update my schedule. That's all for me. Thanks for watching.